All right, so in this example, we're asked to find the sum of the series. And for what values of the variable does the series converge? All right, now these are geometric series. And the way to see it is if you have a common ratio, then you've got a geometric series. So if I look at, minus 4z over 2, it's 2z, right? If I take 8z squared divided by minus 4z, I get 2z, or minus 2z, I should say. So my first value, a, is 2, and my common ratio is just minus 2z. Okay? So this looks a little different because we've got a variable thrown in there, so it's not just numbers. But it's interesting because we can, for certain values of z, we can actually add up the series. The series converges. So the key thing, though, is just that this r value has to be, right? R value has to be less than 1, the absolute value of it, right? And if that's the case, then the sum is equal to the first term, which is 2, over 1 minus r, which in this case is a negative 2z. So it's going to be plus 2z. All right? So that will converge for the case where negative 2z is less than 1. Now, we actually want some bounds on z, not negative 2z. So let's rewrite this as negative 2z has to be between minus 1 and 1. Okay, and so now we can divide both sides by, well, and actually I don't need that negative sign in there because I can take the absolute value of it, so it's just going to be 2z, right? And so so then I can write z. If I divide both sides by 2, then I'll get on the one side, on the one side I'm going to get 1/2. On the other side I'm going to get minus 1/2. So as long as my z value is between negative 1/2 and positive 1/2, then this series will converge to this value, 2 over 1 plus 2z. So that's cool, right? So now we're getting fancy. We're putting in variables. All right, let's take a look at this next example. Now, the trouble with this one is that this first term just kind of is hanging out there. It doesn't seem to match with anything. So if you look for a common ratio, there's no common ratio between, these first two terms, but all of the other terms are just basically x minus 2 times the previous term. So this series is essentially, this part of it is geometric. And it just has a 3 tacked onto it. Okay, so we can kind of just deal with a 3 by itself. And if we look at the geometric part of it, we have a first term of x minus 2 and a common ratio of also x minus 2. And so for the geometric part, well, actually, let's say the sum is going to be equal to 3 plus, if we have a nice r, right? If r is behaving properly, then we'll have the rest of it is going to add up to x minus 2 over 1 minus r. So 1 minus x minus 2. Okay, and I can rewrite that as 3 plus x minus 2 over, now minus a minus 2 becomes 2 plus 1 is 3 minus x. Okay. So we just kind of deal with that 3 separately because it just doesn't fit with the rest of it, but everything else is geometric. So this will be the sum as long as the r value, which is x minus 2, the absolute value of that is less than 1. All right, so let's figure out what the x values need to be. So that says that x minus 2 is between 1 and negative 1. And then we can add 2 to everything, and we get x is between 3 and 1. Okay. So now you might notice that the center of this is right at 2, and our radius of convergence, you can kind of call it. We'll get to this when we talk about power series, which is actually 9.5. But we're going to talk about the radius of convergence and the interval of convergence. So this kind of primes you for that. So you want to hang on to this idea when we get to section 9.5. So I'm going to let you work on the discussion questions, and I'll see you in class.